Hello everyone, my name is Hema Rawat from BSc PCM third year regular batch. My college roll number is 225086 and my university roll number is 22103840101113. Subject is differential geometry and tensor analysis, and the topic for my presentation is dual space contravariant vector, covariant vector and mixed tensor of type 1, 1. Now first we will discuss what is vector space. A non-empty set of vectors, that is phi is not equal to v, is said to be vector space over field f with respect to two operations. First one is vector addition and second one is scalar multiplication. Now what is vector addition? For all u comma v belonging to capital V, then there exists u plus v belonging to v. Now second is scalar multiplication. For all alpha belonging to f and u belongs to v, then there exists alpha dot u belongs to v. इट सेटिस्फाइड फॉलोइंग प्रॉपर्टीज़. फर्स्ट, वी जो है वो प्लस के साथ अबेलियन ग्रुप होना चाहिए. एंड सेकेंड, अगर हमारे अल्फ़ा बीटा एफ में बिलोंग कर रहे हैं एंड यू कमा वी जो है वो हमारे कैपिटल वी में बिलोंग कर रहे हैं, देन ये थ्री प्रॉपर्टीज़ को सेटिस्फाई करेंगे. फर्स्ट इज़ अल्फ़ा ब्रैकेट में अल्फ़ा प्लस बीटा डॉट यू इज इक्वल्स टू अल्फ़ा डॉट यू प्लस बीटा डॉट यू. एंड सेकेंड ब्रैकेट में u प्लस वी डॉट अल्फ़ा इज इक्वल्स टू यू डॉट अल्फ़ा प्लस वी डॉट अल्फ़ा. एंड थर्ड इज ब्रैकेट इन ब्रैकेट अल्फ़ा बीटा डॉट u इज इक्वल्स टू अल्फ़ा इन ब्रैकेट बीटा डॉट u. एंड थर्ड is 1 dot u is equals to u, where 1 is unity with respect to second operation, that is scalar multiplication. नाउ इंटरनल कंपोजिशन. इफ़ अगर हमारे पास कोई भी मैपिंग फाई दी गई है जो हम वी क्रॉस वी के एलिमेंट्स को वी में लेकर जाती है, देन अगर वो हमारा यू प्लस वी अगर हमारा वी में बिलोंग करे तो हमारा ये क्या हो जाएगा, ये हमारा इंटरनल कंपोजिशन हो जाएगा. एंड एक्सटर्नल कंपोजिशन क्या होता है, अगर हमारी कोई मैपिंग एफ आई है जो एफ क्रॉस वी के एलिमेंट्स को वी में लेकर जाती है, देन अगर अल्फ़ा डॉट यू हमारा वी में बिलोंग करे तब हमारा ये क्या हो जाएगा, एक्सटर्नल कंपोजिशन. नाउ नॉट सी ओवर आर कॉमा सी ओवर सी कॉमा एफ ओवर एफ एंड एफ टू द पावर एन ओवर एफ आर वेक्टर स्पेसेस. दिस इज द एग्जांपल्स ऑफ वेक्टर स्पेसेस. Now next topic, basis of a vector space. If V over F is a vector space, then beta is said to be basis of V if first beta is linearly independent, that is Li, and second beta spanned V, that is अगर हमारा L over beta is equals to V over F होना चाहिए. Dimension of vector space VF is equals to number of elements in basis. For example, find the dimension of r square r. Now solution, basis of r square over r is equals to 1 0 and 0 1. Here number of elements in basis is 2, so dimension of r square over r, that is dimension of r square r is equals to 2. If V is a vector space and E1, E2 dot En are basis of V and lambda belongs to V, then we write lambda is equals to lambda 1 E1 plus lambda 2 E2 plus lambda 3 E3 and dot plus lambda n En. This is equals to lambda I Ei, where lambda I is a component of lambda with respect to basis Ei. Now what is change of basis? If Ei and Ei dash are two bases of vector space V, since Ei basis of V, that is Ei belongs to V, every Ei dash is a linear combination of Ei, then we write E subscript I dash is equals to P superscript I subscript I dash into E subscript I. This is linear combination where P Ei dash is n cross n non-singular matrix. In non-singular matrix, determinant is not equal to 0, that is determinant is not equal to 0. Similarly we can write E subscript I is equals to P superscript I dash subscript I into E subscript I dash. Here P superscript I dash subscript I is also a non-singular matrix. Now what is contravariant vector? If V is a vector space over a field of real number, and if M belongs to V and C infinity M is the set of all differentiable function in neighborhood of M, then A vector lambda such that लैम्डा अगर हमारे पास कोई मैपिंग है जो सी इन्फिनिटी एम के एलिमेंट्स को आर में लेकर जाता है रियल नंबर में एंड सेटिस्फाइज फॉलोइंग प्रॉपर्टीज़. फर्स्ट, लैम्डा in bracket f plus g is equals to lambda in bracket f plus lambda in bracket g, where f and g belongs to c infinity m. Second is f lambda in bracket fg is equals to f in bracket m into lambda in bracket g plus g in bracket m into lambda in bracket f, where f and g belongs to c infinity m. And third is lambda in bracket a f is equals to a lambda in bracket f, where a is a scalar and this is equal belongs to capital R and f belongs to c infinity m. Then the set of such type vector defined above is denoted by mm, which forms a vector space with respect to two operations, that is first in bracket lambda plus mu into f is equals to lambda in bracket f plus mu in bracket f, and second in bracket a lambda into f is equals to a lambda in bracket f, where lambda and mu belongs to mm and f belongs to c infinity m and a belongs to capital R, is called space of contravariant vectors, and vectors of this space is called contravariant vectors. Now what is law of transformation of contravariant vectors? Let mm be space of contravariant vector and ei dash are two bases of mm and lambda belongs to mm, where lambda superscript I and lambda superscript I dash are two components of lambda with respect to basis ei and ei dash. Since lambda is equals to lambda superscript I into e subscript I and lambda is equals to lambda superscript I dash and into e subscript I dash, so lambda I into ei is equals to lambda I dash into ei dash. Since ei is equals to p superscript I dash subscript I into e subscript I dash, so यहाँ पे हम लोग ई आई की वैल्यू पुट करेंगे तो हमारा आ जाएगा लैम्डा सुपरस्क्रिप्ट आई इंटू पी सुपरस्क्रिप्ट आई डैश सबस्क्रिप्ट आई इंटू ई सबस्क्रिप्ट आई डैश इज इक्वल्स टू लैम्डा सुपरस्क्रिप्ट आई डैश इंटू ई सबस्क्रिप्ट आई डैश. एंड अगर हम लोग ये वाला टर्म इधर लेकर आएंगे तो हमारे पास ई आई डैश दोनों में से कॉमन होकर बाहर आ जाएगा. तो हमारे पास क्या आएगा, इन ब्रेकेट लैम्डा सुपरस्क्रिप्ट आई डैश माइनस लैम्डा सुपरस्क्रिप्ट आई इंटू पी सुपरस्क्रिप्ट आई डैश सबस्क्रिप्ट आई इंटू ई आई डैश इज इक्वल्स टू 0. Since we know that ei dash is not equal to 0, so lambda superscript I dash is equals to lambda superscript I p into p superscript I dash subscript I. This is law of transformation of contravariant vector. Similarly, lambda superscript I is equals to lambda superscript I dash into p superscript I subscript I dash. Now what is covariant vector? Let mm be space of contravariant vectors and mu such that mu कोई हमारी मैपिंग है जो हमारा mm के एलिमेंट्स को r में लेकर जाते हैं विच सेटिस्फाइज फॉलोइंग प्रॉपर्टीज़. अगर हमारा म्यू इन ब्रेकेट ए लैम्डा प्लस बी न्यू बी वी इज इक्वल्स टू ए म्यू इन ब्रेकेट लैम्डा प्लस बी म्यू इन ब्रेकेट वी for all lambda mu belongs to mm and ab belongs to r, then the set such type of vectors defined above is denoted by mm star and form a vector space with respect to two operations defined by first in bracket mu plus s into lambda is equals to mu in bracket lambda plus s in bracket lambda, and second is a into mu into lambda is equals to a mu in bracket lambda, where mu and s belongs to mm star and lambda belongs to mm and a belongs to r, is called contravariant vector, and vectors of mm star are called contravariant vector. Covariant vector. Mm star are called covariant vector. Law of transformation of covariant vector. Let mm star be the space of covariant vector, and ei and ei dash are two bases of mm star. Let mu I and mu I dash are two components of mu with respect to bases ei and ei dash. So हमारा mu is equals to mu I, ei and mu is equals to mu I dash ei dash. This is equation number star. So हमारा mu I is into ei is equals to mu I dash into ei dash. Since हमारा ei is equals to v p I dash I into ei dash, so mu subscript I p superscript I dash subscript I into e superscript I dash is equals to mu subscript I dash e subscript superscript I dash. सो हम इसको हम लोग इधर लेकर आएंगे तो माइनस में हो जाएगा, एंड ई आई डैश जो होगा वो कॉमन हो जाएगा, तो हमारे पास क्या आएगा इन ब्रैकेट म्यू आई डैश माइनस म्यू आई पी सुपरस्क्रिप्ट आई डैश सबस्क्रिप्ट आई इंटू ई सुपरस्क्रिप्ट आई डैश इज इक्वल टू 0. Since we know that ei dash is not equal to 0, so mu subscript I dash is equals to mu subscript I into p superscript I dash subscript I. Similarly, mu subscript I is equals to mu subscript I dash into p superscript I subscript I dash. These are the law of transformation of covariant vectors. Now, what is mixed tensor of type 1, 1? Since Tij component of vector belongs to mm cross mm star with respect to ei, and ti dash j dash component of vector belongs to mm cross mm star with respect to basis ei dash, are related as t superscript I dash subscript j dash is equals to p superscript I dash subscript I and into p superscript j subscript j dash into t I j. This is mixed tensor of type 1, 1. Now, what is dual space? Since we know that mmr is the space of contravariant vectors, let mu be a function which satisfies the mapping, that is mm is going to r, such that for all lambda and mu belongs to mm and ab belongs to r, then mu in bracket a lambda plus b v is equals to a mu in bracket lambda plus b mu in bracket v. Then mu is called a real valued linear function जो हमारे mm की को हम r में लेकर जाते हैं. Then let mm star be the set of all such real valued functions. We define vector addition of on mm star as follows. For all mu comma lambda comma del belongs to mm star and lambda belongs to mm, then mu plus del into lambda is equals to mu into lambda plus del into lambda. This is equation number first. Define scalar multiplication between mm star and r as follows. For all mu belongs to mm star and lambda belongs to mm and a belongs to r, then a into lambda in bracket a into mu in bracket lambda is equals to a into mu in bracket lambda. It can be shown easily that mm star r is a vector space under vector addition and scalar multiplication defined by 1 and 2 respectively. We call mm star r the dual space of mm r.